Okay, for this problem, we need to find a value r and a value n such that a minus r times I to the n power is equal to 0. And again, we want to find the smallest value of n that does this. So the first thing to do is to go through and find the eigenvalues of the matrix A. And to do so, we're going to take -2 minus lambda, 1, -1, and 0 minus lambda, and take that determinant and set it equal to 0. That gives us -2 minus lambda times negative lambda plus 1 equals 0. Multiplying this out, we get lambda squared plus 2 lambda plus 1 equals 0. And that's going to factor as lambda plus 1 squared is equal to 0. So both of our eigenvalues are the same. They're both equal to a -1. So now we want to go through and look at A minus that lambda times I. And again, we'll do it to the first power and see where we go. So again, matrix A is -2, 1, -1, 0. The value of lambda is a -1. And of course, this is times the identity matrix of 1, 0, 0, 1. And when we find this, we're going to have -2, -1, 1, 0, plus the identity matrix. And that result is equal to -1, 1, -1, and 1. And we notice right away that that is not the 0 matrix. So now let's go through and find A minus lambda I squared. So that's the matrix we just found, -1, 1, -1, 1 squared. And if we square that matrix out, we quickly see that if we take -1 plus 1, we get 0. -1 plus 1 makes 0. And the same thing happens for the second row. So we do get a row of zeros for each, and we get the 0 matrix. All right, so the next thing to do is now find the matrix exponential. And that formula is e to the at is equal to e to the rt times the matrix I there we go. So I plus a minus r times I times t. All right, so for us, that's going to be equal to e to the -t times our I, which is 1, 0, 0, 1. And then we found our matrix A minus Ri already. That was our -1, 1, -1, 1. And again, that's times t. If we simplify this out, that's e to the -t times 1 from the first matrix minus 1 times t in the second matrix, 0 in the first matrix, and t in the second matrix, 0 in the first matrix, and 1, actually it's -t in the second matrix, and then 1 plus t in the second matrix. So that right there is our matrix exponential. And we can go ahead now and find our solution of our differential equation, which would be our y prime equals a times y. That would just be y of t is equal to a c1 times the first column vector, which is -t e to the -t, -t e to the -t. Actually, that was a 1 minus t, wasn't it? So there's a 1 there. So let's erase that real quick. So that's a 1 minus t times e to -t. And then we have c2 times the second, which is going to be a t e to the -t, and then a 1 plus t e to the -t. And so that right there is the solution of the corresponding system for this matrix problem.